In this lesson we're going to learn what we mean by the center of gravity of an object. So the center of gravity is the point in an object through which its weight acts, okay, through which the weight acts. Okay, so we've got an object here, we've got a star on a stick, and I've marked roughly where its center of gravity is by this red dot. Okay, so this is the center of gravity, and that's usually abbreviated to C of G. Okay, and at this moment the weight of the object is acting through that center of gravity, so the weight always acts downwards towards the center of the earth. So at this moment the weight, which is equal to m times g, is acting downwards in this direction. Now what happens if I rotate the object around this pivot, for example, so that it has a new position? Okay, so the weight will continue to act downwards as it does and through this center of gravity. Okay, so it doesn't matter where the star is, okay, even if you throw it in the air and it twirls around all over the place, at any single moment in time the weight of the object will be acting through that center of gravity and it will be acting downwards. Okay, so in your exams questions are often asked with regard to the center of gravity with respect to, for example, the stability of objects. Okay, so you're often asked, which of these objects is more likely to topple over, which of these is the least stable, and these are usually based on qualitative observation. So you get a rough idea of where the center of gravity is, and from that you can decide which will be the least stable. For example, we've got two objects here. They both have the same mass, but in the object on the left the center of gravity is lower down. That makes sense because most of the mass of this object is nearer to the floor, whereas in the second object the center of gravity is higher up. So intuitively we know which of these is more likely to topple over when we knock it. Okay, and that will be the object on the right. You know that. Now if you're asked this sort of thing in an exam question, what you say is the object on the right is the least stable, the object on the right is more likely to fall over because it has got a higher center of gravity, and that really should suffice as an answer. Now we're just going to have a look at this a little bit more closely to see really what happens and why one is more stable than the other. So let's imagine I want to find out what I have to do to make the object on the left topple over. Okay, so I'm going to hit it from this direction, and as a result it's going to pivot around this corner here. So this is going to become the pivot point. So I'm just going to move this point here over there so that we can see the pivot point. Let's see what happens when I knock this object here at the top. For example, it's going to rotate around that pivot point. Now, as we've already learned, its weight acts through its center of gravity. So if I knock it to this position, the weight at the moment is acting through its center of gravity and it will produce a clockwise moment around the point of rotation. So that's going to pull the object back to the ground and it won't tilt over. If I want the object to fall over, then I've got to tilt it a lot further. So we have to tilt it until its center of gravity just passes this line through the pivot point. Okay, so if I release it there, this will still produce a clockwise moment and cause the object to fall back to the floor and restabilize. But if I move it a little bit further past that dotted line, now the weight is acting on the other side of the pivot, and this will produce an anti-clockwise moment which will cause the object to continue rotating this way and fall to the ground, to the floor. So I've got to tilt it a whole long way before it will actually fall over. Now in our second object, again we've got the weight acting through the center of gravity, and what I'm going to do is I'm going to knock this object again from the right hand side so it moves this way, and this is going to be the pivot point now. So we'll move our pivot point and axis over here like that, and now then what do I need to do in order to knock this object over? well, you'll see straight away I've got to move again that center of gravity to a position just to the left of the pivot point. Okay, so it's just to the left of this axis going through the pivot point, where the weight now causes an anti-clockwise moment around the point of rotation. So that's now going to cause the object to rotate in an anti-clockwise direction, and it's going to fall to the ground. So just comparing these two objects now, you can see that I have to rotate the object on the left a whole lot further in order to get it to fall over than I do the object on the right, because its center of gravity is much lower down.